Okay, so hi, I'm going to present OpenDHT. So OpenDHT, it's a project that we started developing along with Ring. So we presented Ring half an hour ago in the privacy room. So first of all, who knows what a DHT is? Just to have an idea. Okay, maybe half, two-thirds of the room. Okay, so OpenDHT, it's a distributed hash table. And who knows what an hash table is? Okay. So the most known DHT implementation existing is the BitTorrent mainline DHT. It's used by BitTorrent to find other people who have a given torrent. So if you've ever seen magnet links online for torrents, so magnet links are actually keys on the distributed hash table that is used by BitTorrent. And the distributed hash table provides a global shared dictionary. And in the case of BitTorrent, this dictionary will be a dictionary between, so it's a mapping between the key, so the key is the magnet link, and the value is the IP address of people having this torrent. So when you have a torrent, you will perform a put operation on the DHT with your own IP address. So it will be added to the list of IP address. So when you want to download a magnet link, a torrent, you will perform a get operation on this same key and retrieve the list of IP addresses from people who previously performed that put operation to register the IP address. And that's how you will have the list of peers that you will then reach directly in peer-to-peer to exchange files. So we use the same idea for Ring to join people and establish peer-to-peer communications with them. But the DHT implementation used by BitTorrent was too limited. So, for instance, the IP addresses that were stored were in clear. We wanted to have them encrypted in Ring. We also wanted to store more kind of data different than IP addresses. So basically, any kind of encrypted or even plain text data can be stored on OpenDHT. So we still begin by forking an existing implementation of the BitTorrent mainline DHT, and we extended it and improved it. So it's still Academia style DHT, just like the mainline BitTorrent DHT. So Academia is just the routing algorithm used in the background to know which node should store which data and what is the algorithm to look for those nodes. So Academia means that the Academia algorithm means that operations will have a complexity of log of n, and n is the size of the network, so the number of nodes in the network. So it's kind of very efficient. I mean, compared to other distributed algorithm, it's very efficient. But the downside of it is that there's no guarantee. It's a best effort network. Yeah. So for this reason, every data is stored on 8 different nodes. So every data, every value stored on the dictionary has a redundancy of 8 to allow people to disconnect at any time and still preserving the value on the distributed network, on the shared dictionary. So yeah, the DHT from the user perspective provides access, as I mentioned, to a shared global dictionary. So it's key value pairs, actually. You can have multiple values for a same key. So it's a multi-map, the structure. Like every map, there are 2 very basic operations you can do on it. You can retrieve values for a given key, or you can store a new value, for a given key. So this is the get and put operations. And for OpenDHT, we also introduced a new operation that is the listen operation. So the listen operation is like the get operation, except that it will, it's non-blocking and it will inform the user when there are new values stored on a given key. So instead of just retrieving the keys at a, instead of just retrieving the values at a given key at some specific time, you will just wait and listen for new values being stored at that key, and that is used by Ring to listen for incoming messages, incoming calls, without doing pooling and without reading values on the DHT on a regular basis. So it's much more energy efficient and it reduces network consumption. So OpenDHT, it's written in C++11. We forked C code and we improved it and made it in C++11, so we can, for instance, have multiple nodes running in the same programs and these kind of things. Use lambdas to have callbacks and yeah, this kind of thing. And we also have Python bindings, so OpenDHT can be used very easily in a very straightforward way by any Python program. It's a Python tree binding. Okay, so recently we introduced new features to OpenDHT. So they were introduced along with the new version of Ring that we presented in the previous presentation. So the major new feature is the DHT proxy. So when you run a node, it will be a local node running on your computers and connecting to other nodes on the distributed network. But this will consume resources. Maybe every few seconds there will be some packets exchanged with other nodes to preserve the network connectivity. And maybe you will receive some messages from other nodes. Make sure that you're still there to store values on your local node. So this might not be viable depending on your requirements. On mobile devices, for instance, it's not really viable to have a DHT node running 24/7 because when your phone is in your pocket, it wants to sleep. If it doesn't, it will just draw the battery progressively because the DHT will just keep maintaining the radio active. It will keep the CPU and the OS active because it will have to wake up on a regular basis to handle the packets and do. Even if it's a very small amount of processing, it will just keep stuff running and it will draw the battery. So there's the need to have a proxy. So the DHT node could actually be running on another computer, and the DHT will completely transparently redirect every operation to the distant node without any change from the code using the DHT node. And we even have the ability to switch on runtime between a local node and the proxy. And this was because maybe we want on a mobile device to use the local node if the device is connected to power or on Wi-Fi, and switch to a remote node if we are on 3G or disconnected from power. And this will allow to have the most distributed possible network while still improving the power consumption when we're not connected to the power.
Okay, so yeah, we also had the ability to have push notification with OpenDHT. It allows us to use, for example, an application on iOS. You can't have a node H24 on the iOS device. So because Apple will kill your app. So with push notification, you can ask the proxy to send a wake up notification to wake up your application and retrieve the value from the DHT. We also rework on the protection on DDoS things. So for the proxy, it's just a simple REST API, which is described on the wiki, and you can switch. So let's have a little demo. where is my? Okay. We have a proxy on DHT proxy.ring.cx for 8000. Oops.
So since the DHT proxy API is it's a REST API, so we wrote a simple DHT client in web with JavaScript. So the proxy API actually also enables the use of DHT from web apps. So web apps can connect to the proxy server through the REST API and use perform operation on the DHT.
So I will use the proxy to put some value on random hash. So it takes some times. And after that, I can get values from the DHT. So this is retrieving from the proxy. And we also have the listen ability. So if I put, we will have a real-time streaming. So this is for the demo. And yeah, for the push notification, we use a gateway. For the gateway, we use a Gorush REST API. It's open source and under MIT license push gateway. And the thing is, we want the push notification systems as distributed as possible, but push notification is centralized by default because you have what we call a push provider, like FCM for Android or APN for Apple. And you need to authenticate your notification to the push provider. So you need to store a key or a password somewhere. So we have a push gateway hosted by Savoir-Faire Linux. It's push.ring.cx. And this central server, you store the data, the key and the passwords for APN or FCM. So each node can create a notification with just a device ID and ask the push gateway to send a wake-up notification or a timeout notification if the listen expired. So this is the new feature for OpenDHT 1.6. If you have any question, you are free to ask. And thank you. I didn't.
Yeah, so you can have, of course, yeah, yeah. So the network starts at 2 nodes. You can have two nodes, and it works. I mean, it works even better if there are less nodes. It's a log of n, so it's faster. It's a bit faster if you have a smaller network. Yeah, sure.
Yeah, for example, text messages for Ring. Okay. He asked if a value on the DHT have a expiration time. So, yeah, for example, for Ring, if you send a text messages after 5 minutes, it will be deleted from the DHT. So, ah oui. Poisoning.
Yeah, so every value will expire at some point, but yeah, so the question was, is there a mechanism to avoid poisoning of the DHT? Yeah, so it's part of the value expiration system. So actually, we have some mechanisms so that if some given IP address floods the DHT, it will not have priority for values. So if some other IP will want to store a value, then so there is a maximum value. So it's 8 megabytes per node, and so if 8 megabytes in memory are used, then the values from the IP using the most storage will be dropped. I mean the oldest value from the node who stored the most data will be dropped to avoid the poisoning and but yeah.
The question is basically, do we have an entry point to the network? And yeah, we have bootstrap.ring.cx. It's the entry point of Ring OpenDHT network. But you need to connect your node to the network, so you need any entry point on the server.
So just a precision, you don't have to connect to bootstrap.ring.cx. You can use any running node on the DHT network as an entry point. It's just that bootstrap.ring.cx is a known running node of the network. So you can use this reliably to connect to the network. But if you know some other node running, you could also use this other node to connect.
What's the maximum size for a value, and what values are people using and getting good results with in practice?
So the question is, what's the maximum size of a value on the OpenDHT? We limit a value to 64 kilobytes.
Yeah, so we are based on the BitTorrent DHT, which is the largest DHT, I mean, maybe the largest distributed network actually running in the world. They have more than 10 million nodes. So they use the Kademlia, it's a Kademlia style DHT, just like us. Actually, we are based on the same basic algorithm. And so it's, yeah, it run, if you can download a file using BitTorrent. If you have a magnet link, it will be between probably less than 5 seconds to get the list of peers from the DHT. And it's similar to what we observe in the DHT, in our DHT. Almost always under 10 seconds, and most of the time less than 3 seconds for a get operation to retrieve a value. Yeah, of course, there are multiple kind of DHT networks like CORD, but yeah, we just use the mainline Kademlia DHT style